Okay, so ladies and gentlemen, welcome back. So today we've got this question, and the question reads: a spherical brass ball of density 8890 kgs per cubic meter is hanging from a ceiling attached to a wire. The tension in the wire is 150 newtons. What is the radius of the brass ball? So in this scenario, we are given the brass ball, and then we are told tension that the ball is hanging, and then they want us to calculate the radius. So in other words, they want you to find the relationship between the tensional force and the radius, of which the moment you hear something like that, you should know that the tensional force and the density, usually they meet somewhere. There must be something that links the density, the volume, the tensional force. So we'll find that as we solve this problem. So this is the little information that I had to deduce, since they are saying we have got this brass ball. So this one is a freeboard diagram. This is a brass ball which is being hanged onto the ceiling, and then they told us that the tension in the wire is 150. So you should definitely know that if something is hanging, it's being affected by the force of gravity. So you expect it to have weight which is equal to mass times the force of gravity. So this is the situation that we have. So for the purpose of solving this question now, we must recognize what we have here. So if we are to collect all the forces that are acting in the y-axis, so we are taking our Cartesian plane as this is the positive y and this is the positive x. So whatever from this brass ball going up, we're taking it as positive, and whatever from this going down, we're taking it as negative. Okay, so let's try to put that into practice. So from there, so we can say sum of all the forces in y. Since this system is not moving up or down, it means these forces, they are balanced. The ones that are in positive y-axis, they are equal to the ones that are in negative y-axis. So we expect sum of all the forces in y to be equal to 0. Which are those? We have got the tensional force that is going up minus the weight that is going down. So T minus weight, these should give us a 0 like this. So if we are to take W to the other side, T will be equal to W, where W is equal to mg, which is equal to mg. And from this question, you are actually given that rho, which is the density, is 8890 kg per cubic meter, and then you are also told that T is equal to 150, and you know that G is equal to 9.8 meters per second squared. This is what you know, this is what you were given. So you can come here and substitute what you can. T, that's 150, is equal to W, which is equal to mg. M we do not know, but we know G, that's 9.8, like this. And then you can divide both sides by 9.8, and then if you do this, and then if you punch in your calculator, you then find out your M is something close to my calculator is saying 15.3 kgs, like this. Hopefully we are together, right? So this is going to be your M, that's the mass of the brass ball. This is going to be your M. Now from this information, they can't just give you this. No, they can't just give you this. You know there is a relationship between density and the mass. So that relationship, usually they say density is equal to mass over volume. Density is equal to mass over volume. So in this case, since the question is saying what is the radius of the press bore, they need you to get the radius of the press bore, of which from this information that you have here, the only set of instruction that can give you the radius, it's only V, because you know most that when you're dealing with something that is spherical, V involves R. The formula usually involves R. So let's try to make V subject of the formula. If we make V subject of the formula here, our V is going to be equal to, our V is going to be equal to M divided by rho. So we can take this situation now and try to solve. So since V is equal to M over rho, in this scenario we have the value of M, which is 15.3 kg, and then we are given from the question the value of rho, which is 8890. So we can come and plug that in, units kg per cubic meter. Remember, this which is equal to this which is equal to this is said to be equal to V. But how do we calculate the volume of a sphere? Because here they are saying it's a spherical ball. So the volume of sphere is given by what? Let me write it here. Volume of sphere is equal to 4 over 3 pi r cubed. This is the formula to calculate the volume of the sphere. So you can just take all this information and plug it in place of V. So you have your 4 over 3 pi r cubed, like this. So if we simplify this, I'm not quite sure, but my calculator is telling me that if you simplify that, remember the units, they will cancel, and then our final answer must have cubic meters as the final unit. So my calculator is telling me that if you punch this, you expect to have something like 0.017 cubic meters. Please confirm this. And this is the one that is going to be equal to 4 over 3 pi r cubed, like this. So yeah. So now, remember the question wants you to get the value of r. So to get that, you divide both sides by 4 over 3 pi. So if I divide this side by 4 over 3 pi, and then I divide this side by 4 over 3 pi, like this, I'll have the value of r cubed being equal to what? If I punch that on my calculator, I'm getting something like this. Please redo this, because I'm using the calculator of my phone. I'm not quite sure. So this is our r cubed, but the question wants us to calculate the value of r, so we just put cube root. So r is going to be the cube root of 0.0004 cubic meters, and that will give you what? According to what I'm getting here, it's 0.074 meters. So this now is going to be your r. Hopefully it's clear, ladies and gentlemen. So your question has indicated to you that you've got density, you've got the tensional force, and then you can actually convert that by linking the relationship between density and volume as well as mass. So you are required to calculate for mass first. As soon as you get mass, you give us the relationship between mass and density. So you are required to calculate mass, that's the first stage, and then after getting mass, you have to give us the relationship between density, mass, and volume, that's the second stage. And then the third stage now, you have to make R the subject of the formula. That's somewhere here. That's somewhere here. And then as soon as you do that, you can get all your marks. Hopefully it's clear. I tried, guys, to try and make it as clear as it can. So yeah, that's the situation. Let me know if you have questions. Bye.